Find the difference quotient for the following functions. I think we're going to do 2 in here. I think there's 2 extra examples in the Math 1521 videos, so be sure to watch those. So this is the formula for the difference quotient. Remember, as defined in Chapter 1, when we talked about functions, I said you want to think about it as f evaluated at whatever is in those parentheses. So if this said f of 9, you would say 5 times 9 minus 3. F of 20, 5 times 20 minus 3. Well, we have f of x plus h. So what is that going to turn into? Yeah, 5 times the quantity, x plus h, and then top it off, minus 3. 5, the new x, minus 3. So make sure you're plugging x plus h in for x. This notation does not say tack an h on the end. That's not correct. Minus is this minus here. Minus the function itself. Well, the function is more than one term, so what should I put around it since it's following a subtraction? Parentheses. 5x minus 3. All over h. So if you remember that one problem we highlighted where it was g of x is x minus 4 over x plus 3 in your homework, and I'm like, we really should do part E. This is the reason why, because you have to get used to this x plus h notation. Sure, so we have 3 parts. The last part's easy because that's just a h. Second to last part is not as easy, but in comparison, minus the function itself, 5x minus 3. The first part is this guy, which is the f of x, plus h. So what this says notationally is that wherever you see an x in the function, you're going to replace it with x plus h. So f of 6, 5 times 6 minus 3. F of kumquat, 5 times kumquat. What is a kumquat? Minus 3. So you're putting this in for that x. This x here in the x plus h is not this x here in the function itself. We call this a dummy variable, means it could represent anything. It's representing x plus h here. Once you have that, that's hurdle number 1. Hurdle number 2 is simplifying. It's just algebra from here. What should you do with this 5? Distribute. What should you do with this negative 1? Distribute it. So distribute the 5, we get 5x plus 5h. Minus 3 copies down. Minus 5x plus 3 all over h. Now, we have a polynomial function, 5x minus 3. Typically, things cancel. What happens to the 5x's? And the 3's? What was Gretel's brother name? Good job. It rhymes with cancel. Upstairs, you're left with 5h. Downstairs, you're left with h. Love changing colors. What happens to the h's? 5. Sure. So the whole idea was, instead of saying 2 different x values, a and a b, we now say one x value and the distance to the next x value. And we call that a distance h. So that forces this to now be called x plus h. So it's still like f of b minus f of a, but instead of 2 distinct x's, you're now saying one x and a distance to that next x. What type of function is this? Linear. What's the slope of this line since it's linear? So that means if you were to pick any 2 points on this line, 5x minus 3, and find the slope between them, what would you always get? 5. Oh my gosh, we did all that work and we already knew what the answer was. Wah, wah. However, for anything else, it won't be that nice. In calc, you learn how to do this in one step. We're not there yet. We have to go the long, exciting way. Yeah. So difference quotient would be a slope. Now here's the deal. Notice that this is just a number 5. Because no matter what 2 points you pick, the slope stays the same, i.e. it's constant. However, as we're going to see, if we had a different type of function like a quadratic, depending on the 2 points you pick, like if I pick these two, the slope would be, oh, I missed that point completely. The slope would be negative. But if I pick these two, the slope would be positive. But then if I pick this one, the slope would be close to 0. So, meaning that once we go higher degrees, your slope is variable, meaning you're going to have an x involved still.